All right, I'm with the Cadillac 2000 Cadillac Deville. Now I'm at like I didn't already go through this and diagnose this problem, but I just want to give a more smoother transition to what I did to isolate the problem with the complaint. Now the complaint is customer do not have any type of cruise control. Here's the cruise control module here. Locate, I can't even get it out right. Located right at the left side of the engine compartment, right here by the air filter. All right, we're gonna do some basic tests here. If you do have any bidirectional capabilities, I'm gonna go through some basic stuff with that. There's nothing complex about this. This system does not have any CAN gateway system or control area network to where it has bidirectional capabilities. There's nothing special about this. So with that said, I do have a basic, I pulled the wiring diagram and I just print that out real quick. I'm gonna go over that real quick, what I'm looking for, what I was looking for, and what should happen versus what's not happening. And being that this doesn't have any bidirectional capabilities, it's not like we can go into the computer system and analyze the functionality of it, what's happening, what's not happening, because usually when we go into a module, this is a module, but when we go to like some type of computerized module where it doesn't have any type of mechanical actuation, it's electronically controlled. I don't want to say mechanical because I'm just using it as the cable. You have PIDs or information you can analyze that will give you vital information such as voltage, which we will have to manually check on our own. In this case, we can also look at, in some cases, I'd imagine if it was like some type of bidirectional capabilities, actuation function taken in consideration, like HVAC servo or blendor actuator, you'll be able to look at the variance in voltage based off the actuation. This doesn't have that capability. It's just basic stuff. So with that said, here's the wiring diagram. The system has 10 pins at this module. It's very simple design. There's nothing complex. The first thing we're going to do, we're just going to isolate the power that goes to this cruise control module. Let's see if I can get my pin here. We're going to first test the ground right here. That is going to be E, which is the black wire. The only component I'm going to use is a test light here. It's very simple. You can use a multimeter, but it's best just to do a load test on everything because it's a possibility you can get biased voltage. In this case, I'm gonna tell you, it's not biased voltage. That wasn't a problem. But always, if you have to use a voltmeter, use a voltmeter, just a digital voltmeter here. It's fine for tracking wires. Make sure you're on the proper wire and stuff and continuity test. But when you want to legitimately load test something, this is it. This is a 300, 400 milliamp test light. This is capable of illuminating and supporting a load. This is going to reassure and assure us that the wire integrity is legit. So what I'm gonna do, since we're testing ground, we're going to pin E, which is the black wire. This is a 10-pin system. We're gonna hook right up on a power source, so positive side of the battery. We're gonna look for ground. What should happen, this test light should short and illuminate, just like that. So I'm gonna pull this. Shouldn't have to worry about anything. There's not gonna be a check engine light because this module is pretty much a dumb system. Pin E should be, let me see if I can zoom in a little bit for you. Pin E is black. Black is not on this side here. There's A. It does have the alphabet written on it. A, B, C, D, E. There's our black. We're going to take our probe, pierce in there. We have some illumination. So we can check E off because we have a power source. I'm sorry, not a power source, but our low side reference, which is our ground. The next thing we're going to do is we're going to check the power, which is going to be our ignition, which is the pink wire. That's F. F is next door to it. Testing this power source, I'm going to take my test light and I'm going to hook up the alligator clamp on a ground source. So instead of positive, looking for a negative, we're going to go to negative to search for a positive. So this pink wire, the key's in the on position, but here's the thing, based on the wiring diagram, if we go to our ignition source, here's this pink wire, it runs all the way up and over to an under hood fuse block, which is this 10 amp fuse. It should be constantly hot, and we should get an illuminating test light. We do. There's another fuse source. Let's mark this out here. So we checked our power going to the ignition. There's another power source here. All right, next we're going to check the next power source. It's the cancel input right down at the bottom, right there. This is going to be D. It's the purple wire. All right, now this runs all the way to the brake pedal. From what it looks like, the static state is a constant 12-volt source. So when this TCC cruise control release switch near the top of the brake pedal, when this gets depressed, it breaks that circuit. So it cancels that 12-volt source going to the cruise control module, which will deactivate the cruise control. So logically, by reading this, the natural state of it should be constant 12 volts. So let's check that. And it should be terminal D, which is the purple wire, terminal D. Let's go there. So we're going to leave our test light on battery positive. That's D. So there we go. There's our purple. We have an illuminating light. So we can go ahead and knock that off. Where we at right there? Booyah. So we tested 3 wires. We tested our powers. We tested our grounds, and we got the other ignition power there. So the other function that I would want to check is the cruise control on. All right, because we have to have some type of activation through us. Okay, we should want to command this unit to activate. Is that switch working? Now, based on the wiring diagram here, that on-off is the gray wire down at the bottom. This is pin A, very first one. It goes from cruise control module through the clock spring here. This is the clock spring that's in the steering wheel. Over and shares a junction with the gray wire that goes to the resume and cancel, set and coast. So this shares a mutual 12 volts. And why I say 12 volts is because if you look at the switch here to activate it, it doesn't ground it out. It comes from a 12 volt source, that same IG1 fuse, ignition 1 fuse, that 10 amp. You can see that's bridged there in the fuse box. So this should be a constant 12. Logically, you know, I would want to diagnose this by going right at the airbag. It was just seemed like it was a little too much to pull that airbag out. Me having to fish for those springs at the steering wheel. So I took another route. So this should be constant 12 volts, just as our brake switch was when we tested that cancel input. All right. So what I'm going to do, I'm going to link up with this gray wire. I'm going to link up the gray wire, and I'm going to put this on, I'm going to leave it on ground because I'm looking for 12 volts. Our gray wire is going to be here. This is A. This is what we're going to be linked up at. What I'm going to do, I should be able to push that switch. If If I can get that to hold right there, I should be able to push that switch and it should hold and it should stay illuminated. So let's see what happens. All right, there's our cruise control switch. Push it and nothing happens. So let's see what happens with the light. The light's not illuminated. All right, so you can kind of get a context clue what we got going on. But check this out. If I hold it, the light stay illuminated. Let it go, nothing happens. Let me show you what that looks like under the hood here. So we pushed it, the light illuminate, and then it didn't, and it ceased to do that. So if I push it and hold it, let's see what happens. I'm pushing the button and holding it. I'm letting it go, nothing's happening. Pushing and holding, nothing's happening. So you get an idea of what's going on, that we have a problem with the button. So you see that we have a problem with the button. One thing that I'm going to do, I'm going to put a question mark right here at our button there. So A is questionable. And I want to circle our problem. If I can get this to hold itself, don't laugh at my circle. Don't laugh at it. So that's likely going to be our problem. What this answers is that we have our voltage source coming from that fusible link down through the switch. I push the switch, that voltage goes to the gray wire, out through the clock spring, all the way down to our connector here. So assuming that we have good voltage, we should have constant voltage. This is not working because it doesn't have constant 12 volts. I haven't done this additional test that I was thinking of, but what if I apply constant 12 volts to the unit? Can I manually actuate this on my own? Now, there's a couple things that has to happen because we have something that tells it not to work. And the safety protocol is going to come from that PCM right down there. That's the inhibiting function. That is this green wire here. This green wire is pin H, the cruise inhibit. After a certain speed is achieved, the PID data, this is where the scan tool comes into play. The PID data is going to change. To access this information, what you'll do, you'll go into the PCM, go into the powertrain control module, go into live data, go into the engine data. Now, I had to search for this, and I found it in engine data 3. Oh gosh, hold on. I should have seen this coming. There was no power up there, but me talking and trying to give some direction. So we're going to type in cruise here. C-R-U. There we go. It's already pulled up for us. So here we see the cruise inhibit signal command here. Inhibit basically is the impede. So the impede signal is on. It'll become laxed or off or enable the ABS unit to work when it achieves a certain speed. That was about 35 miles per hour. So I can't bypass this logically until that's achieved. But being that this system is kind of dumb, it sends a, I want to say it sends a ground signal. And how I determine this is I can go to active test, engine, cruise control disable right here. Now I can, the inhibiting state is on. If I turn it off, all I got to do is simply take my voltmeter, go into that green terminal, that pin where the green wire is, which is pin H. I can go to pin H and put my lead on either a power or a ground source and see what happens. So let's do that. Here we are. So here's our green here. This is H, right? Yep, this is H, dark green wire. So I'm gonna just let this sit right on in there, like so. And I'm gonna simply go right into my scan tool and push a button. I'm on ground. Here we go. I'm just gonna push this button right here. Push on, so it's on. I'm gonna push off. So our inhibiting changed command to off. So we should have an allowance, or we should be enabled to activate the cruise control. I'm on ground, there's nothing. So if it was to illuminate, that will indicate that I have positive voltage. So if I go to positive, which calls it to illuminate, that indicates that this is a ground signal. So to enable this ABS, this cruise control to operate, I need to supply a ground signal. So if I was to trick this system, which I'm going to attempt, and we're going to see if we can get that throttle to actuate. Well, I need a 12 volt source from the on button, and I need a ground source from the inhibiting function to activate it. So I think I should jump those and see what happened. Now, to be all fair, I don't know what's going to happen, but logically, this should work. All right, I'm powered up. I have my power here on the gray wire. I have the inhibiting function off, so it's enabled. Let's see if I can get this to actuate. I don't feel it actuating. It's not moving. So what's supposed to happen is when I push the resume in Excel, I'm supposed to get battery positive right here on pin D. So what I should do is hook up a test light on pin D and see when I push the resume Excel if that's responding. Let me try that. Yeah, the purple wire. Wait a minute. I was wrong. So the D is the gray and black wire. It's C, sorry. So I should be hooked up on C. Here's C. So when I push the resume button or Excel button, it should illuminate. That should give the command for this unit to actuate, and it's not. Could this unit just be bad? Or is it like outsmarting me, huh? Could we have a bad module or something? So the stop lamp signal input here, pin G, is an open circuit. So if we follow this white wire all the way up to this junction here, this connector near driver's seat, go on over to stop lamp switch near pedal, it's naturally an open circuit. So if this sees 12 volts for the stop lamp fuse, this would deactivate the system also. So this system doesn't need to be jumped or anything. We have our power, we have our ground, we have our cancel input, power, resume request, cruise control on. We have our constant signal there because I've applied 12 volts. Push that, and that's stuck. So I got constant 12 volts going to that. We have jumped through the computer the cruise inhibit, engagement out. That should just be confirmation, unless the vehicle speed has to be jumped also, because remember, after a certain amount of speed, then it tells this unit to work. Well, I guess the module is smarter than me, because unless the vehicle speed input has an influence once it reaches a particular speed, I can't like jump it and manually control it. So I'm not sure how that reacts with that module internally. But the only thing that we didn't test was K, and that's the speed line there. And based on the directions, I just like, let me go ahead and read the directions, because ain't that smart. The direction state is supposed to generate a square wave, but we knowingly know that the switch is bad. So what I'm gonna do, I'm not gonna film everything, you just gotta take my word for it. I'm gonna drive this car, and I'm going to just hold the button for the on, for the on button, and then see if I can control the cruise control. That should work, unless there's just two different problems, like the module's bad and the switch is bad simultaneously. Because I'd imagine logically, like if I can I can enable it to work, provide the power source it needs, why can't it command itself unless it's the speed sensing mechanism inside of there? So that's the only thing I can think of. So let me try this and let me see what happened, and I'll get back with you. I'm gonna let this engine run for a little bit, because I'm diagnosing the misfire simultaneously while diagnosing this unit here for the cruise control. So I have the Altel MP408. I think they wind up discontinuing this. I'm on channel B. I'm gonna start off with 20 volts DC. What we're gonna do, I think I wound up like misdiagnosing something else, because the cruise control still isn't working when I hold this switch and administer power while driving. So if I hold the switch at the steering wheel, logically it should work. So the only thing that I didn't check, even though we checked every single wire on here, was the vehicle speed input. As for the directions, I'm supposed to see a square wave. So let me finalize this diagnosis for this cruise control unit by assessing and seeing if we have a square wave. I do have the front wheels jacked up, and by the wiring schematics, this goes out to the engine control system. So shit goes to the vehicle speed sensor. Engage input. I think, let me see, vehicle, here you go, right here, 26. Let me see, yep, okay, vehicle speed output, and then input. I think maybe, without me looking at any other wiring diagram, I'm not sure if this is integrated with just one signal wire for the vehicle speed sensor. So I'm just going to see if I got a square wave when I put it in drive, and if I do, then not only is the switch bad, but the actual unit is bad too. So let's see what happens. I'm on a 20 volt DC scale here. So if we get a square wave, it should be more like a digital type waveform. And so we should see a square wave versus an AC wave, a sine wave. I'm hooked up on the last one, the K pin. Only thing left I have to do is set a time base, which that is too fast. I like 50 milliseconds. Start it, and let me see what happens. It's going 10 miles per hour. And what's up with this? What did I do wrong? I don't have vehicle speed here. Strangely, I don't have vehicle speed unless there's something wrong with my connection. Let me test my system. Oh, you know what? The reason why it's not working is because I don't have my ground hooked up. Duh. See what happens when I hook up the ground. There you go. Got my ground hooked up. We have a square wave. So it's a 12-volt square wave. So this lets me know I've tested every single thing on this unit. We got powers, we got grounds. We don't have switch. We have our vehicle speed sensor. We can command the inhibitor to ground out and still no function. So likely what's happening is that there's just communication inside this unit. There's a problem. Let's see here. Let's see. So we got everything we need for this to work. Everything. Vehicle input. We got confirmation. And so after I get a certain speed, it'll actually engage the cruise control with the inhibitor. Engagement output. So I think this right here is just going to be the fact that when this does duty or does some type of work, this gets sent out. Okay, that's what I think. And all the brake switches and everything else, I mean, those are working. We have all the necessary components for a working module, and it's not. So there's obviously some type of communication going on inside of there that's creating some issues. I could disassemble it just to look inside of it because it was made in 2000s. I don't know how simple it is, maybe worth looking into. But at the moment, this unit is bad and the switch is bad. So we're gonna have to replace both of those. But at the moment, this was just a diagnostic video. So we'll see what happens in the future. And I'm definitely gonna update when we do get these units to see if I'm correct. But if anything happened, hit that link, subscribe to the channel, stay informed how to research my work. And I'll see you on the next one.